Hey everyone, thanks for joining. We're going to give it a few minutes to let folks filter in to our July monthly demo. Just sit tight and we'll get started here shortly. Hey everyone, if you're just joining, we're going to wait a couple more minutes to let some more folks filter in and we'll get started here shortly. So just sit tight and we'll kick this off in a couple minutes. All right, we are a couple minutes past the hour, so I'm going to get started here in just a minute as a couple more folks filter in. Thank you all for joining us today for our July monthly demo on Kubernetes application backup and recovery. My name is Andy Gower. I'm a solutions marketing manager here at Portworx, and I'm joined by tech marketing extraordinaire Ryan Wallner, who's going to join us for a demo later on. So throughout this call, throughout this webinar, please feel free to ask questions. Ryan and I are here to answer them. We're happy to answer questions throughout the presentation. At the end of the presentation, want to make sure this is an engaging conversation. Before we get to our primary topic, though, I want to set the stage for what we're doing with Portworx overall, what we're doing as a business. And to do that, we have to take a step back and think about data. And think about how data is powering the business of tomorrow. How I think everyone on this phone call, everyone on this webinar has probably come to realize that data really is the fuel that's powering businesses forward. And that's something that's only been accelerated with the past 16 months with the increasing move from analog to digital under our COVID conditions. So as data becomes the power, the fuel for the business tomorrow, we're also increasingly seeing digital leaders take a new cloud-native stack approach to process this data into value and insights. They're building a new platform that's built upon this multi-cloud infrastructure, letting us run applications anywhere in more places than we ever have before. And because of the scale of these new applications, we're investing in new parts of the stack like Kubernetes and containers to automate these to automate this stack, to take advantage of the automation capabilities Kubernetes brings to the table. And on top of that, we're often using open source databases like Cassandra, Kafka, and Elasticsearch to completely redefine this cloud native stack. And because we're building this new cloud native stack, we're also seeing a shift in how we're actually building the applications, the tools we're using, the processes we're using, the rise of things like DevOps and GitOps and the SRE. And what's really driving this change more than anything is containers and Kubernetes. Containers and Kubernetes are the core of the cloud native revolution. And we see that in the numbers. So 95% of new apps are being developed in containers. 78% of CNCF members are using Kubernetes in production. 81% are working with 2 or more public cloud providers. And 85% of global businesses will be running containers in production by 2025. But, and there's always a but, as great as container platforms are, they don't address the storage and data management requirements that enterprises have, at least not in a way that's truly automated, scalable, and turnkey. Of course, given time, given money, given unlimited resources, you could cobble something together. But the question is, when push really comes to shove, when you really have a true production environment, do you have the storage and data management in place to address critical requirements around HA, DR, backup, and more? Can you do things like protect your sensitive user data? Can you do things like easily move between the clouds? And the problem to date has been that the virtual machine world, the machine-based world, just doesn't support this new cloud native stack. But that is exactly what Portworx does. We deliver a modern data experience that cloud native applications require, so you don't have to choose between performance, security, and availability, data protection, and trade off with things like automation, ease of use, and self-service. We give it all to you in a single platform. And for those of you who are just learning about us, maybe this is the first time you've joined us on a webinar, we're the leader in the space. We've been recognized by GigaOM as a leader in 2 recently published reports. The one on the left is for cloud native data storage. The one on the right is for enterprise Kubernetes storage. And this builds on last year's report where we were also named as a leader. And in fact, the quote from GigaOM is that Portworx sets the gold standard for Kubernetes storage. Our customers are some of the largest and most sophisticated users of Kubernetes in the world. And the reason I put this slide up here is simply to say, if you have a challenge or a problem, we've solved it for another customer, and we can use that expertise and that insight to help you avoid pitfalls as you continue along your container journey. So how do we do this? The way we do all of this is with the Portworx Kubernetes Data Services platform. In a nutshell, it's a single platform for any stateful application in any environment. We know that our customers are often building large-scale Kubernetes platforms that don't just run one database. They might have a dozen different data services, each backing 1 or more microservices. They might be using Kafka and Elastic and MySQL and TensorFlow and putting it all together. So rather than learn and become experts in each and every one of them, they have a consistent platform with Portworx to manage each and every one of them. In addition, we know that many of our customers are embracing a true hybrid multi-cloud environment. They're using a Kubernetes distribution on-prem. They might be using a different Kubernetes distribution for the public cloud. They might be using different infrastructure in different places. They might be using multiple clouds. They might be using Pure in some cases. They might be using NetApp in other cases. Maybe they're using some IBM, some bare metal. The point is, what Portworx provides is a software-defined layer that is completely agnostic. So we can support our customers wherever they choose to run, and we can support them through every stage of the journey, whether that's in the pilot stage, the dev test stage, all the way to the production stage. Now, Portworx itself is composed of 6 primary modules, and the main topic for today's conversation is the one on the bottom right, PX Backup. So we'll come back to that in a couple slides. We'll go in a little more detail there. But just to briefly touch on the other components of PX Enterprise, starting with the top left, PX Store. Portworx Store is the built from the ground up storage that provides cloud native storage for an app running on-prem, in the cloud, or in a hybrid multi-cloud environment. PX Migrate is all about allowing customers to easily move applications between clusters for hybrid multi-cloud mobility. PX Secure provides container granular encryption and access controls so that you can scale while maintaining security as you scale. PXDR is focused on high availability replication between availability zones, regions, and clouds, and is focused on providing 0 RPO downtime within the Metro Center. And PX Autopilot lets you auto scale while reducing your storage costs. So rather than having to buy all the storage you need up front on a cloud infrastructure, you can scale as your application grows on that cloud. Now, before we talk about PX Backup, I do just want to call out 4 areas where we have had a lot of success helping our customers accelerate their digital transformation. The first is around speed with T-Mobile. And I really like this case because T-Mobile has a couple of things that they struggle with, or that they are challenged with. The first is they have surge in demand at specific times during the year. So think about it. Every year we've got an Apple event, we've got Worldwide Developer Conference, we've got a big Samsung launch event. And at these events, we're launching the brand new iPhone, the brand new Samsung Galaxy, the brand new iPad. And someone like T-Mobile sees a surge in traffic immediately after on their website that's unprecedented compared to any other time of the day, any other time of the year. At the same time, they may have to roll out a new marketing campaign or a new application to help deal with these new products that are being offered. Well, before they were using Portworx, it took them something like 6 months to deploy an app, from conception to actually deploying it. By using Portworx, they're able to bring that down to hours. So now they can have an idea from marketing, a new launch from Apple, and conceptualize it and deploy it in the same day. So that speed is hard to value, but it's critical to T-Mobile finding success. The next is agility. So Roblox is a really interesting one. Roblox last year at the beginning of the pandemic scaled as much in 1 week as the previous year combined, as much in 1 week as the previous year combined. So think about that. Your business has a generational shift in demand, and you're trying to figure out, how do I scale? How do I make sure that the users stay engaged, that the users have access to what they need? With Portworx, we're able to provide that seamless scalability. We're able to provide them with the agility they needed to keep their business up and running as they saw this generational increase in demand. The next is RBC. So RBC has been using Kubernetes in many ways, but they faced a dilemma. They wanted to take an important banking app and put it in production on Kubernetes. Now, that sounds simple, but there are some business requirements they have to fulfill. The big one being they had to be able to survive a complete data center failure with 0 data loss. Working together with Portworx, we're able to give them 0 RPO failover, completely independent data centers, so they could feel comfortable putting that banking app into production on Kubernetes with the reliability they needed to make sure it was always up and running. And the last one is Audi Business Innovation. So Audi didn't come into containers and Kubernetes and working with Portworx to save money. They came in for speed, for agility, for reliability. But along the way, with our PX Autopilot, they were able to cut their AWS storage bill by 60%. So not only did they get all the benefits of containers and Kubernetes, they also cut their bill, which at the end of the day is a win-win for everybody. Okay, so now that we talked about PX Enterprise, I'm going to double click into PX Backup and talk a little bit about our approach to backing up and protecting your Kubernetes applications, what we're doing, how we approach it, how we think about it, and then I'll turn it over to Ryan for a demo. So before we jump into that, I want to just call out, again, like we are a leader in the enterprise Kubernetes space, we're also a leader in the Kubernetes data protection space. This is the Giga radar from last year, the most recent one, that named Portworx as a leader in Kubernetes data protection. So we're in this space, we're a leading force in the space. We continue to drive this space forward amongst our competition. Now, backup is essential for the enterprise, and it's essential as you move apps in production for a couple of reasons. Really 2 in particular that stick out to me. The first is data protection. Many enterprises, it's about, how do I prevent a data loss in the event of exfiltration, or in the event of ransomware, or in the event of some other event? How do I keep data loss? How do I mitigate my losses from that event? The other is compliance. So something like GDPR or HIPAA or CCPA that requires you to be in compliance with specific regulations around your data and how you manage your data, how you back up your data. And for many enterprises, it's both. It's data protection and compliance. On top of that, for most enterprises, there's another factor. It's, I have to be able to recover quickly. I have to be able to recover quickly to avoid downtime, to prevent a poor customer experience, and to avoid an SLA penalty. So we're faced with these challenges. How do we put an application in production? How do we back it up? How do we make sure that we prevent data loss? How do we make sure we're in compliance? And how do we recover quickly? Now, the first thought might be, well, let's use our traditional backup. Let's just take our traditional backup tool and apply it to Kubernetes. But that doesn't quite work. Our traditional backup is machine focused, but as we know, containerized apps run across multiple machines. So if you've got a backup that's focused on a single machine or a single server, how does that scale to support a containerized application that's running across multiple machines, multiple servers, multiple nodes? Second, a traditional backup doesn't speak Kubernetes. And what I mean by that is our container backup often requires us to support Kubernetes concepts like namespaces and configurations. If the backup doesn't speak Kubernetes, how can it provide support for those concepts? How can it truly back up everything we need to recover down the line? And last but not least, traditional backup is centrally managed. But as we know in the container world, everything is driven by the end user. Everything is driven by the person who's building the app, who's running the app, who's deploying the app. And the same is true with container backup. So how do we take a traditional backup that's centrally managed, yet also let it be driven by the end user? That's something that's difficult to square. Now, unfortunately, 75% of IT professionals wrongly believe that containers can be backed up the same way that their applications are backed up, despite all those things I just mentioned. And the result of that is that when you rely on this traditional backup for your Kubernetes applications, your apps and your business are left exposed. Since you can't just back up a specific application, you have to continue backing up the entire machine. So you have slow, expensive ETL procedures when you restore. You also potentially deal with data loss. If you can't back up the configuration or the Kubernetes objects, how do you know how to rebuild your Kubernetes application exactly the same way it was before? That can lead to data loss. That can lead to problems replicating in the new environment. In addition, recovery is slow. You can't offer self-service. There's a lot of manual intervention, and compliance and governance are often black holes. So again, when you're relying on a traditional backup approach, trying to apply to Kubernetes, there's a lot of holes that just don't square and really cause problems if you go down that road. And I think GigaOM sums this up better than anyone, better than I can. And they said, without container granular backup options for Kubernetes, enterprises are exposed to data loss, downtime, and lost customer loyalty. Okay, so what are we doing about this? What are we doing about this problem? How are we addressing it here at Portworx? That's why you're here, right? And so that is why we created PX Backup. PX Backup delivers enterprise-grade point-and-click backup and recovery protection for all your applications running on Kubernetes, even if they're stateless. It was built exclusively for containerized applications, and it protects the data, the app configuration, and the Kubernetes objects with a single click at the pod level, the namespace level, or the cluster level. And it also natively integrates with major block storage systems like EBS, Google Persistent Disk, Azure Managed Disk, as well as Portworx PX Store. And we see the benefit from this immediately. Whereas before we see a traditional application doesn't have application awareness, PX Backup does. And what that means is we can back up any app running on Kubernetes at the pod, tag, or namespace level and back it up to any object store. And then we can quickly and easily recover it to any Kubernetes cluster running in any environment. This also enables us to provide a secure self-service backup and restore experience. So for example, we can enable the developer user type to have permission to back up and restore their apps. We can also give them permission to have app and namespace granularity. So we can empower them to do their own backups and provide the self-service that we want. Next, we can take our app owners and in addition to those permissions, we can give them permission to set schedules, to set rules, and to use existing cloud accounts. And then we can have our admin have additional permissions to add users, create and share cloud location or cloud accounts and backup locations, and create custom roles. And what this does is gives us a comprehensive, secure, self-service backup and restore experience for our enterprise. Now, when we think about PX Backup, there are really 5 key things we want you to take away, 5 key things that we think make PX Backup unique and a leader in this space. The first is that PX Backup is container granular. That means you don't have to back up the entire VM. You can back up just the containers associated with your particular application. So it's more efficient, less costly, and it also reduces your restore time. Second, as we mentioned before, PX Backup is Kubernetes namespace aware. That means we can back up not only a specific set of containers, but we can back up an entire Kubernetes namespace. So you can back up all your Kubernetes applications with a single click. Traditional backups, as we said at the start, they don't even know what a Kubernetes namespace is, so they can't provide this capability. Next, It's common to run distributed applications on Kubernetes, and these apps are often backed by a distributed database like Cassandra or Kafka. You might have some Elasticsearch in there or MongoDB. PX Backup is able to provide an application-consistent backup of these distributed systems to ensure application consistency when you back it up and when you restore it. Next, as we talked about, it's not enough just to back up the data, and it's not enough just to back up the app configuration. You have to capture the entire app. You have to capture the volume, the app config, and the Kubernetes objects. And that ensures that we have a seamless backup, and we have fast recovery. And that's something PX Backup is able to do. And last but not least, PX Backup is optimized for a multi-cloud world. What that means is PX Backup is able to, this opens the door for PX Backup to provide local and wide area network disaster recovery across multiple environments, public clouds, Kubernetes distributions, and on-prem. It lets us have different environments for production and recovery. It really opens up a world of benefits because we're able to support this hybrid multi-cloud world. So with that, I'm going to turn it over to Ryan in just 1 second for the demo. Before I do, I want to call out 3 things that you can do if I hopefully piqued your interest, or Ryan and the demo is able to pique your interest. The first is that we have Portworx Essentials, which is our forever free option. We've got a Portworx Enterprise, which is a 30-day free trial, full featured, and then you can turn it into a monthly pay-as-you-go or an annual contract from there. And last but not least, we have a free 30-day trial of PX Backup, and you can take advantage of all these things I just talked about. So with that, Ryan, I'm going to turn it over to you for the demo.
Sounds good. Thank you, Andy.
Let's see you there.
All right. All right. Thank you, Andy. So Andy, you talked about some of the main features around PX Backup, and I'm hopefully going to touch on a lot of these. Things like container granularity, namespace awareness, application and configuration. And we're going to do this sort of in a live PX Backup system. Where I wanted to start, though, is if you are new to Portworx or PX Backup in general, where you want to go to get started is definitely head over to central.portworx.com, which it'll bring you to this landing page. You can use Google or GitHub. I choose to often use my GitHub account, and it will lead you to an installation page. And this gives you the options that Andy talked about in terms of choosing from Portworx Essentials, a free enterprise trial that's unlimited for those 30 days, and absolutely PX Backup, which we'll be talking about today. So if you wanted to install PX Backup, it's also free for 30 days. You would select this button here and click on next. And this will guide you through how PX Backup is expected to be installed and what types of configuration you're going to be installing it in. So for instance, if you were running your Kubernetes cluster on-prem, you may select on-prem versus, if you're running an AKS or EKS in the cloud, you can select cloud here. And keep in mind that PX Backup actually requires some backend state itself. It is itself a stateful application. So it does require a storage class. Often in Portworx environments, this is a Portworx storage class here, which you can see I've used in the past. And that will guide you through effectively using a Helm installation command to both add the repo and give you the installation command as a one-offs kind of a string, or it'll give you a values file that you can reuse in the future. Now, I've already gone ahead and done this because it takes, I think 10-15 minutes to actually boot up a PX Backup system. That's probably on the high end, but definitely head over to central.portworx.com to get started, and that's for both PX Backup and Portworx Enterprise. After you're done, actually, you'll have access to all your saved files. You can get demos, access to online courses, even access some support. So definitely go ahead and check that out. So I have a PX Backup environment here that I'm going to connect to. So this is deployed in AWS, and like I said, already connected and installed with PX Backup. So here we go. And in here is my backup UI. So this is the login page for PX Backup. When you connect, you will have sort of a blank slate here. I've gone ahead and connected two clusters to my PX Backup instance already. If you're wondering what this looks like, installed in Kubernetes, let's take a look at the PX Backup namespace, which it gets installed into. There's a lot of things going on here, but if you have a healthy running PX Backup instance, this is kind of what it'll look like. It's deployed as a native Kubernetes application itself. Again, this is UI. So let's cover a little bit about how we go ahead and configure PX Backup before we're ready to actually back up any applications. So we mentioned backup locations in the presentation. So I'm going to start there, right? So if you head over to cloud settings, you'll have two main settings here, cloud accounts and backup locations. Really, this means is where are you going to be backing up your applications to? So a cloud account may be an on-prem S3 compatible interface, so you'll wind up using sort of an S3 based cloud account, or there's other ones that you can use such as Azure and Google Cloud. Today, S3 is the only compatible backup location. I think NFS is planned in the future. And you would give it a name and some information based on the cloud account, whether you're at Azure, AWS, such as access key and things like that. So I've gone ahead and already done that. Again, I've set up my S3 cloud account, and then my backup location, I gave it a very generic name, AWS, but it also points at Amazon S3. So again, you would select your cloud account and select your backup bucket. Optionally provide an encryption key. This is anything you want, so it's more of a phrase to provide encryption for your backups, the region, and everything like that. So once these two things are configured, cloud account and backup location, you're pretty much all the way there, besides adding your Kubernetes cluster and backing up an application. So how do you back up add a cluster? We'll start there. There's this big button in the top right, add cluster. We target using the kube config file. So if you have an existing Kubernetes cluster, the control plane needs to be accessible from wherever PX Backup is. So if you're on-prem and you're sort of behind some firewalls, make sure PX Backup can access your control endpoints, the API server for Kubernetes, or if you're in the cloud and has a public account such as an EKS, it'll select your cloud account that you've also created some of the backups locations with, or you can create a new one that has access to your EKS clusters, and it will manage configuring access to that in that fashion. So this little command, you would copy this, and in any Kubernetes cluster, you can go ahead and just select that, grab that whole file, paste it or download it, and add your cluster. So once that happens, your cluster will be added to this main page here. And you give these clusters a name. And to dive in and actually back up an application, let's dive in. You click on one of these and you will be presented with this screen. So you'll have sort of a menu of applications, backups, restores, and schedules where you can see any existing backups that do exist, which I have one here, no restores, no schedules, and this drop-down menu for namespaces. Now, one thing we talked about in the presentation was namespace awareness, right? So you can back up an entire namespace. So if I were going to back up, say, the demo namespace, which I know has a front-end application in it that uses a stateful application of Postgres. So here I have a Postgres service and a Postgres PVC. You can go ahead and just select the namespace and back this whole thing up by clicking backup, right? And that's actually what I had done originally to create sort of a base case. But we also talked about container granularity, meaning that if you just wanted to back up a PVC, this is my PVC here, and persistent volume and persistent volume claim, I can go ahead and kind of deselect the actual resource to just really back up that PVC, which gives you this granularity of selecting sort of at a per PVC or per container by selecting Postgres here, or it's actually a deployment, right? The type is deployment here. So it's really flexible in terms of exactly what you want to back up with what type of backup, meaning that if you had a scheduled backup that just targeted the PVCs, but you had another backup that targeted some of the configuration state, that's completely possible and flexible. The other option here you have is you can back up by type. So I specifically selected that myself, but if I had more than one namespace selected here, and this is this application awareness, right? Where my applications may not exist all in one namespace. I may have my data services in one namespace and another data service in a different namespace. So I can go ahead and select a whole another namespace. And the output from this will be both namespaces and everything within them in one view. But now I may say, okay, I may have a lot of PVCs in both of these namespaces. So it allows you to select by the resource type. So again, I can go ahead and select persistent volumes. And across two namespaces, I get a backup that looks consistent across these two applications, and I'm just grabbing the data, right? Now, an important piece of this is that Portworx allows you to back up application data, meaning the resource such as deployment, service, config map, and the data, persistent volume claims, and persistent volumes. And so we give you the option to back up one or the other or the whole thing as a unit. So if I were trying to configure backup as sort of application and configuration at the same time, I'd probably select all, or at least select the main parts of my application, which is going to be select all in this case, and it will back up all of this right in one fell swoop. Now, there are other ways to do this. I think with larger amounts of application data and application resources and types, you may have thousands of PVCs in your cluster, right? So for me to say back up all PVCs is a good one-off solution, but really doesn't give you that fine grain exactly know what's going on. So many applications in Kubernetes today have labels. So I'm going to go back to this demo namespace only, and we may choose a label, right? So here you can see, obviously I have one label in this labels column, and it's called app KAS-counter. Now I could search for this label, or I could just go ahead and select it, which I've done here. And when you select it, it will grab all the resources that are associated with this label specifically. So again, the point I'm making here is that PX Backup is very flexible in terms of how you actually back up your application. Do you want to back up all the data and that's it, all the PVCs? Do you want to back up all of the multiple namespace, every namespace, really, or by label, right? And so it's very, very flexible here. So now let's go ahead and sort of reset and see this thing in action. So I have an application here deployed in the demo namespace. As I said before, it is a Postgres server with a web front end. And if we click on the screen here, we get some database records being added to our Postgres database. And so every click I make, it records where I'm clicking and adds that to the database. And so now I've essentially added data to an application. And I want to take a backup at this point. Now, obviously, this is one very specific type of application, but the same idea is I'm adding data to a stateful service, and now I need to go ahead and back it up. So I'm going ahead and select my demo namespace and everything in it. I'm going to click backup, and I'm going to say, I'm going to give it a name, case backup. We'll say 2. We'll select our namespace location. There's a lot of things going on in this menu, and I'm going to stop here to just explain a little bit of it. We're going to run a fairly basic backup. So that means I'm going to select a one-off backup, meaning now instead of on a schedule. If you do want to use a schedule, you can create a schedule. There's one created here. Again, that allows you to do things like backup every hour, every 15 minutes, every Tuesday at 4, those kind of things for compliance. The CSI snapshot class, now, by default, Portworx doesn't need to use CSI and the snapshot classes. So if you're running Portworx Enterprise underneath it, it will identify the type of volume. So if I had actually, it might show it afterwards, but it'll identify the PVC and what backend it's using. So in this case, it's all running on Portworx Enterprise, so it's a Portworx volume, and therefore PX Backup understands how to make the snapshots and gather that information. But if you weren't using PX Enterprise, this is another thing to keep in mind for PX Backup users, is that PX Backup does not need PX Enterprise to run. Meaning if you're running on AWS and using the native EBS volume driver through CSI, you would be able to select the CSI volume driver for EBS here and still back up your applications that are using other types of volumes besides PX Enterprise volumes. So, point being is that PX Backup can be used with or without PX Store or PX Enterprise. Moving forward, we don't have any rules, but we will give a example if we have some time about what a rule looks like. And these values, we can give an arbitrary value for purposes of management as we're looking through our backup. So let's go ahead and take a backup. Essentially, what this backup is doing is backing up the data that we have in our application, which is the 10 records that we selected in there. Now, the volumes will be backed up first, and then the resources of the application will come next. If you want some details about what's going on, you can click Show Details, which gives you some information about when the backup started, how big it is, the status of what's happening. So right now the volume is being backed up. The type of volume I mentioned before, it's identified here as a Portworx volume with that little Portworx icon, and then everything that's in your backup. So here I can see I have 2 deployments, 1 persistent volume, and 2 services. And so this is everything, again, which is data plus configuration, right? Volumes and resources. Really important to back up your applications as a unit. We can see that now it's complete. It's successful, and so if we look at this details again, it should have the same sort of status. So now at this point, we have this as a restore point, meaning that we can restore this exact piece of the exact data and configuration of this application. So to do that, right, so let's add a bunch more data. Just go around here so we make it obvious after we restore about what's going on. So we filled up this page. We have 26 records. We started with 10, and we want to go ahead and restore and say something went terribly wrong. No one was supposed to click on that page. We can go ahead and restore this, right? So this is what a restore workflow looks like. Again, you give it an arbitrary name. A lot of the times I like to give names that are a little more meaningful. So I'd give a name of the app. And we'll just say it's our first restore. In terms of destination, Portworx is multi-cloud. Andy talked about this as well. at this point, I have just 2 clusters in AWS. I don't have another cloud set up. But if you were connecting to a GKE cluster or Azure cluster, you can absolutely select this for your destination as well. So again, you can deploy this to cluster 1 or 2. I'm going to take the most basic scenario and say I just want to restore back to a good known state in my existing application namespace in the same cluster. So I'm going to select cluster 1, and I'm going to keep the same namespace. So if you wanted to restore to the same cluster but a different namespace, you'd select custom restore, and you can effectively give a whole different namespace here if you wanted a demo 2 or restored, as your namespace, and it would go ahead and create it there. But for the purposes of what we're going through is, I know we're going to restore to a good known spot, and I'm going to make sure we replace existing resources because I do want this to be restored in place. And we're going to select the default restore here. So let's go ahead and click restore. Let's head over to the command line at this point, and SSH over to our other cluster, and we're going to do a watch kubectl get pods in the demo namespace, which we are restoring. So as you can see, the restore is already doing some work, meaning that in order for it to restore in place, I selected replace existing resources, so it's terminating those resources on my behalf. I selected this to happen. It doesn't happen automatically. It won't delete stuff unless you ask it to. And at this point, you can get the same type of information about your restore as you did with your backup. So you can see my volumes are already restored and our application resources are now in progress. Let's head back over here. So now there's successfully cleaned up that namespace. We can see the restore is in progress. Our volume should be completing shortly. And now we see brand new containers up and running. Postgres is up and running. And this is probably completed by now. Yep. And so that's the size of the restore. And so again, a lot of the same information you can show in these details. And at this point, I should be able to go back to my application here, give a quick refresh, and we're back to those 10 records, right? So this is showing you that, we did back up from a point in time, restore that from that same point in time, and we're back to what we expected with our 10 records. And again, this is all with sort of one-off commands. Now, if we head over to schedules, right, if you wanted to do this at a sort of existing sort of policy that you had in your organization, say you needed to retain a certain amount of backups for your SLAs or whatever it may be, you can configure these. So this is a periodic schedule which backs up every 15 minutes, and it will retain up to the last 12, right? And again, PX Backup, when using Portworx, uses sort of delta backups too. So because Portworx understands sort of what's in the latest volume and backup, it will kind of do this on a sort of a delta basis and save you overall space as well. So to use this schedule, we can actually take a very similar approach to what we did before and select the demo namespace, back it up, and select the same thing here, KS counter, and we're going to give it sort of a schedule name here. This time I'm going to select the schedule, use example, and that's the only difference, right? We can give everything else the same information. And now it will back up a version of what you created initially, and then it will use that schedule every so forth. So at this point, you can see when we click on schedules, now we see our Kubernetes counter scheduled backup. And again, the options here are to see some details and suspend it. So if you wanted to, for a time being, suspend your backups, you can go ahead and do that. You can show details about when the whether it's active, next scheduled backup, when it's happening. We can see we don't have a time here because it's actually happening at the moment, and all the resources that are selected. So this is really useful if you need those schedules. So again, they will show up in your backups as well as your schedules, right? That's the difference here when you're using backups. And obviously restores, we did that before. So in terms of multi-cloud, right, what I can also kind of show you here is that our second cluster here doesn't have the same applications we were just working with, right? It only has, it's basically a blank slate, just Kubernetes running with no applications on it. And what we can do here is go back to our backups, select we'll select this backup, which had 10 records. We can restore this. And we'll say cross KS backup 1. We'll select the second cluster this time. And we want to back it up. Let's say we'll back up to, we'll just give it the same namespace because we already know it doesn't exist. And we know there isn't any resources in that cluster in the namespace because again, it doesn't exist. So we'll go ahead and restore that. Now, what is happening is that it's backed up from cluster 1 and restored to cluster 2. So in this case, our original backup continues to work, no problem. And we can add data to it. And we can head over to our other cluster and see here that if we look at namespaces, our restore actually created the namespace for us, right? It didn't have to pre-exist. PX Backup was aware that we're backing up to a new cluster. It doesn't exist, so let's go ahead and restore it like it was in cluster 1 and cluster 2. So now we can get the same information about our pods in cluster 2. So now we have the same application running in cluster 2, and if we take a quick look at our services, again, it's running at the same port. So this is the first cluster we were working with, and I want to say, let me go to my instances that we're running in real quick. Let's grab a node from the second cluster. So this is the second cluster, grab a node here. That's how that works. 30123 and boom. So here is the restored in the second cluster, but we're accessing it from that second cluster, and it's the same restore point. So you can see this is entirely different cluster, different records, and restored to another one. This is how it would look, across different clouds too. Again, it would just come up with the same data and everything. So I do want to leave some time at the end, but I do want to touch on one more piece of what I mentioned, which was rules. Backups use snapshots in this case, and we need to make sure applications are consistent, right? So say you have a Cassandra deployment. In this case, I have Cassandra stateful set, which has 3 different nodes, 1, 2, 3 here. And each node has a PVC. Now, I want to make sure that my data is flushed to disk and backed up appropriately using those mechanisms. Now, this is what we call application awareness. And to do this, you would head over to your rules and create a new rule. And we can say Cassandra pre-rule. We will select app equals Cassandra. Again, the pod selector has to be a label. And so we can add that. And our actual container within this pod. Some pods have multiple containers. So if you have like a init container and a main container, this gives you the ability to target where this rule runs. And so we're targeting Cassandra, and we want to say no tool flush to flush everything. And we can run in this case, we want it to run in every Cassandra pod. We want it to flush all that data in every single so it's application consistent, and we can add that rule. And so now we have a Cassandra pre-rule, and to use this, we'd head over to the Cassandra, whatever namespace Cassandra is running in, or we would target Cassandra with labels. We would select backup like this, and we'll do Cassandra back 1. Backup location would be the same. Now the different part of this is in the pre-exec rule, we're going to select our rule, cas pre. So this is saying that before the backup occurs, before data is backed up, we want to run this rule. So that rule flushes data to disk. And again, we'll go ahead and create that rule. And that's it, right? That's how you kind of select that rule to make sure things are running. You can see that the pre-exec rule is being run in those details. And this gives you sort of an added kind of assurance that backups are application consistent and not just crash consistent, and it really goes above and beyond for your Kubernetes applications. So I think I touched on a lot of pieces here. We're at 10 minutes to the hour. So let's see if we have any questions. If you haven't asked your questions yet also, feel free to post them in the questions box of the webinar. I'm getting my window back up. Andy, I don't know if we see any at the moment.
Yeah, I don't see any in the chat. Please send some in if you have. We can answer them, and if there's something else you want to see Ryan show, if you have a specific question about something he already showed, if you have any other questions, please feel free to drop them in the chat now, and we'll get to them.
Okay.
And if not, Ryan, I don't know if there's anything else you want to touch on while we wait and see if there are any questions, or.
Well, I can show you that our Cassandra backup was successful. And again, the difference here is that each Cassandra node has a volume itself. And so that rule ran on every single pod for application consistency. And so we can see that, our backup has 3 PVCs here. And again, you'd be able to restore it in a very similar way that you have here. And everything is sort of shown here when it comes to what schedules you have, how much data you've protected, how many apps you've protected, which is a really good sort of visual to how you're protecting your Kubernetes environments.
So we've got a question from John. He says, security, using SSL certs, admin user and authorization integration for PX Backup, backup and restore failure scenarios, or failure PX Backup in a data center. So can you talk a little bit about the security that's in place, both access security and then also in the case of a failure for PX Backup, how we make sure the data stays secure?
Yeah, so what I touched on in the version of PX Backup I'm showing here is that in the backup locations, these settings, obviously for backup locations, you can provide encryption keys, SSL endpoints. Obviously, you try not to disable SSL here. Again, we can use sort of SSL to communicate with that backup endpoint and do the encryption of the data before we actually send it to the S3 back endpoint. What I'm not showing here is the role-based access control and user integration that we have in sort of the shortcoming release that's coming up. And that allows you to not only give access to specific users and groups, but also give those groups ownership of specific things. So not everyone would be able to create a backup location. Not everyone would be able to create a backup, a cloud account. That may be reserved for admins in a group that you've designated in sort of an LDAP or a sort of user integrated, something like Okta, and you can connect that to PX Backup. And then you'd have another group for users that may have access to specific things like just creating a backup but not deleting backups, or creating a restore but not deleting a restore for audit control and things like that. Again, that's not shown here, but we do have it coming out shortly, and it will be able to use in that fashion. What else am I missing there? Yeah, so really just sort of RBAC controls layered on top of this. What you're seeing here is an admin view. And even if a user of Kubernetes in a cluster has access to PX Backup and has a limited access to PX Backup, meaning they would be able to create a backup, the way that they add clusters, because it is sort of self-service, a user would come on here and add a cluster and post their kubeconfig, right? So, users are often given a specific kubeconfig or token that also ties into the Kubernetes RBAC piece of things. And so that kubeconfig file and token within it may also limit their access to, as the namespaces that they can see. So if I came in here and posted a kubeconfig file that was reserved for, say, just the default namespace or a specific namespace, when I click on a cluster here and select namespaces, I wouldn't see all these namespaces. Now, I've added the clusters using an admin kubeconfig, and I'm logged in as an admin on PX Backup right now. So I do see everything, but it would be a limited list reserved for just what the user has access to on Kubernetes. And then again, PX Backup has its own controls, which can limit what a user can do within PX Backup. I hope that answers the question there. If not, let us know.
Yeah, and I think we're getting to the top of the hour here. That is the last question I see, but I do want to touch on something off that. You touched on this briefly. Can you talk a little bit about how PX Backup can be paired with PXDR to kind of give an enterprise a full disaster recovery model and really kind of take advantage of PX Backup beyond just the capabilities you talked about here?
Yeah, so PX Backup is one piece of the puzzle when it comes to data protection and business continuity, right? So PXDR is another one of our offerings that uses a similar core technology in the back end here, meaning that we can create disaster recovery scenarios between clusters. And it happens a little differently. So in PX Backup, what you saw today was really sort of a one-off or a schedule of, I want to back up this specific thing. I'm going to create a restore or restore when I need to. PX Backup allows you to create sort of what's called cluster pairs. And so what allows you to do is in this instance, if you had two clusters like this, you could pair those clusters together. And effectively create a migration object. And that migration object says that you can target, again, at a very granular level, specific applications, entire namespaces, multiple namespaces, and it will continuously sort of back up and do a backup and restore, but what we call migration, right? It's a similar movement to a backup and restore. And it allows you to sort of turn on or fail over in a single command in a disaster scenario, meaning that it's continuously doing this for very low RPO and RTOs. And if you're using Portworx, you can actually go down to 0 RPO by stretching a Portworx cluster across 2 data centers, meaning that data is replicated always to both data centers. And so you can actually get 0 RPO and very low RTOs for the application to come back up. So combining the power of sort of PXDR with a more traditional backup solution, you can have both sort of a hot standby site for those disasters that require really fast failover, and a more sort of long-term backup data protection solution with PX Backup. So definitely both complementary to each other, but use similar technologies.
Perfect. So I think that's, go ahead, Ryan.
That's it. I do want to just mention, if you are looking to get started with PX Backup, again, central.portworx.com, or head over to backup.docs.portworx.com for all the documentation.
Perfect. And we hope this is helpful. Please feel free to reach out to either of us. Our emails are on that first slide, and you'll get a thank you from us. So please feel free to reach out with any questions, any comments, any follow-ups to this. And we hope to see you in next month's demo in August. We'll have Bhavin here to talk about Tanzu. So please join us for that. And thanks again for joining us for today in our demo here in July. Thanks a lot.
Thanks, everyone.